Hello, my name is Eric Baker. I'm the Vice President of Product Management for the Construction Machinery Solutions Group here at Aztec Industries. Today we're going to talk about in-place recycling and some of the differences between cold in-place and full depth reclamation and so forth. So we'll jump right into it. A big part of this process is doing the proper thing on the road and job site selection and choosing the right treatment. So for new pavement, when you're creating a new pavement, usually if you're going to be running a reclaimer on the existing or the soil, that's what we would consider stabilization. So kind of new construction is going to be more in the stabilization realm. If we're recycling or reclaiming an existing pavement, then we're usually looking at cold in-place recycle, cold central plant recycle, or full depth reclamation. And really there's a few significant differences between these processes. So cold in-place recycle is usually going to be 3 to 4 inches deep. We're not going through the entire pavement structure, so we're not going all the way through the asphalt structure. So usually sometimes that's referred to as partial depth recycle. Our intention there, and we'll get into some more details, but intention there is to really break up the crack structure. Cold central plant, so cold in place is obviously done on the road in place. We're not hauling material to a site or anything like that. Cold central plant is really in essence the same process as cold in place recycle. It's just not in place. We truck the millings or wrap to a centralized location and mix that material, but it's kept cold. We don't reheat the material with some sort of either foamed asphalt or emulsified asphalt, and then bring it back to the site or stockpile it for a different site later. Full depth reclamation is, like the name sort of says, is full depth. We're going all the way through the asphalt structure and we're really creating a new foundation or base. So it's 6 to 12 inches deep, really as deep as we can compact, going all the way through the base. And then all of these processes are typically going to be overlaid by some sort of surface course. So whereas cold in place, we're really just putting a wearing course and sort of a sealing course on top. Full depth reclamation, we're really building the pavement on top of that. But we can typically get by with thinner pavement because we've upgraded the base. So those are the real categories here, and some of the terminology. A lot of times these get mixed up and people will call it all in place recycle, but these are the ARA standards. So ARA is the Asphalt Recycling and Reclaiming Association. I actually a good resource for anybody that's wanting to know more about these processes. Please feel free to contact me through Trenton or anyone there at Virginia Asphalt Association, and they can get you in touch with ARA. Virginia Asphalt is a member of ARA. So, but what this looks like in sort of application, and this is an old photo. This has been around for a long time in different forms. Obviously, you can see kind of by the age of the equipment and the graininess of it that this isn't a new process. So really the traffic count, like any pavement and any process, is going to determine depth and structure and mix design. But just kind of rules of thumb, typical depth somewhere between 2 to 4 inches. We can mix with 3 to 4% emulsion. Sometimes they'll add lime or cement depending on stripping aggregates, what sort of initial strength we need if we want to turn it over to traffic, those sort of things. And there's good labs and engineering firms that can guide you there. Also the contractors that are doing this have a lot of experience on what would work best. And then also we can use foamed asphalt, and typically that is done with cement. And we'll just kind of rule of thumb, but it can be overlaid with a lot of different things, but just sort of a basic would be overlaying it with 1 to 1.5 inches of hot mix on top. So just give you kind of an idea of what this looks like in practice. Now that picture previously here is a really simple train, mill running essentially backwards from the way it would normally run, feeding directly into a paver or mixing in the cutter housing, and we'll show some more details on that. But then you get into, you can also do big long trains, and there's some advantages to both. This sounds coming. So this video is from a construction piece in Utah. They do unit trains. This is multi. One advantage of these multi-units is sometimes they can be set up, depending on the piece of equipment, they can be, the same unit can be set up in a central plant configuration or in a cold in place train. There's also other products out there that are specific to cold central plant. There's a lot of different ways to do these applications, a lot of different pieces of equipment, ways to skin the cat, but really the process and the way the result is the same. Hopefully that gives you some ideas or background on what this looks like. Of course, mentioned that can be set up as a cold recycle or cold central plant as well. And what that would look like is something like this. aeration on this one. Where unit pulling people into the site, milling, wrap are brought to the site, and stockpiled there. Set up. Now they're going to keep that wrap onto air. This is in Brazil, a little less sophisticated of a process. Still very normally you'd have a maybe an opera or something like that. It's a little easier. Small sites, you can just feed it right conveyor belt. So, and it will then feed into the screen deck, hug mill, and so on. Basically, getting that same sort of hold in place recycled product. Feeding up screen deck. Anything oversized like that piece there would then go through a crusher. This is the advantage of these larger units is you have closed loop sizing. So going to get whatever, however you set up the screen deck, 1.25 inch minus or inch minus, however you want to set the screens up. Crush on board so that you size those and then they go once it's upsized, go through a puck mill. Asphalt. Yeah. So then there is full depth reclamation, and typical FDR process might look like so. So there's a few different types of FDR. Mechanical, where we're really just pulverizing the material, not adding any additive to it. We're just going to basically reorient the material, add some water, and then recompact. Chemical, which is where we add a chemical additive, Portland cement, lime, and some other similar cementitious type products to create a new base. And then there's bituminous, which is going to be emulsified asphalt or foamed expanded asphalt. And possibly, or maybe most likely, going to include some Portland cement or lime in those bituminous processes as well. So looking at these different processes kind of through the pavement structure, you have an old pavement, cracked, maybe a little rutted. One option would be to just overlay it, kind of a very temporary fix. You might get a 50% improvement on the ruts and crack, but the cracks are still going to reflect through. Another very common process that's going to buy you some more time over just a straight overlay and make some more improvements is that mill and overlay or mill and fill. We got to fix the ruts, fix the geometry, but still those cracks, if we don't remove them, they still will reflect through. Then you have cold in place recycle. So cold in place, you can see it there. It's that intermediate layer. And because of the structure of cold in place, it's actually a little higher air void content than hot mix. Cracks really don't propagate back through it. You can see it's a little thicker because of that slightly higher air void content, but we end up with the overall same strength as far as structural coefficients. So, and it just doesn't have that structure to let the cracks reflect through. So that will increase the pavement life and service life of that pavement even farther and extend the curve even farther. Then you have full depth reclamation, where we're really reclaiming the material, reclaiming the pavement, and rejuvenating it to the point of it being a new base. And you can see that there. So this is straight from the ERA Basic Asphalt Recycle Manual. I won't go into too much detail here, but you can see different pavement distresses. This is a good resource that's out there for you, and some different potential processes. And you can see CIR covers a lot of the cracking, and then full depth reclamation is going to be more into the structural part of it. So when to CIR, cracking is a big one. Some patching, rutting, geometric issues, if they're not too deep, we can correct those. And then full depth is when your base is failing. If you have a road that's carrying more traffic than it was ever designed for, that's when full depth reclamation really shines. And you're going to do a condition survey, maybe some sampling or by coring or trench milling. Falling weight deflectometer is a big sort of pavement selection tool here. So you're trying to determine what the cause of the pavement distress. If it's functional, more on the top surface, CIR is a good candidate. If it's structural, then full depth reclamation is going to be more likely. Just some experiences out there. Kansas DOT, they've got 29 years, well now even more from when this was captured, but a lot of cold in place recycle experience out there. And you can see their typical mix design. It does include some lime. They expect a service life of 5 to 10 years with little standard maintenance. And the biggest thing is it costs about 45% less than 4 inches of hot mix. Nevada DOT. So this is comparing to, the other one was comparing based on sort of cost per service life. This is, if they were, and for Nevada, they consider CIR, 3-inch CIR with a double chip and a 2-inch HMA overlay as having the same 10-year service life. And they find that they have achieved $104,000 of savings per centerline mile looking at those two processes. So that savings, 10-year service life, plus lower maintenance costs. So this is something you might be familiar with, obviously, the AASHTO structural coefficients. And looking at these, you can see HMA, HIR is hot in place recycle, CIR, FDR, and so forth. Now what they found in Ontario, up in Canada, where they do a lot of cold in place, they found that the structural coefficient of CIR is 0.28 to 0.38. So CIR has 66 to 90% of the strength of HMA, and really they found that on average they're finding 0.35. So you have kind of that AASHTO range, which is pretty broad, but from their experience, it's closer to that top side of the window. So that would be 83% of the strength of hot mix. So looking at that, if you were to compare to similar processes, CIR versus a mill and fill, for example, you get a 40% increase in structural number value with the hot mix layer there. But the CIR has a 30% less cost. So we're getting 80% of the strength for 30% less cost. So the cost strength benefit is in favor of CIR. Also, when you look at sort of the life cycle cost analysis of different applications. Now this material is from Sahila Bamanian. She was the executive director for the DOT out in Nevada, where they did a lot of CIR. She's now a consulting engineer, but still in the industry. And they did a lot of research into CIR and really rejuvenated rehabilitated sort of their program. They have so many lane miles, but I guess per capita, that their tax base really, funding is a challenge. So they had to think outside the box. So they really brought CIR and FDR into their program on a heavy basis. And looking at these sort of costs, you can see CIR really shines. Obviously, full removal and reconstruction is the most expensive, and really doesn't gain you as much service life as some of the others. Of course, there's all the other sort of benefits. we're conserving energy, natural resources, reducing carbon emissions, therefore, and then some of the other things we've talked about. When you're looking at carbon emissions, this is a study from AMEC, Earth and Environmental up in Canada, and looking at CO2 emissions, traditional practices, so more of those mill and fills, those sort of things, overlays versus recycle. Because you don't have that trucking, ends up in a 37% reduction in CO2 emissions. And just more environmental material, CIR, the takeaway here is CIR requires 80% less energy than HMA. And this is from Colas study that they did. So just getting into some different, and these pictures are going to be heavy on road tech slides, but or pictures, but Orkin also has very similar equipment and offerings. But really the sort of two markets that have evolved out of this is single unit, where we're doing really everything except the paving with a milling machine. So see on the left here, the RX 900, it's operating in its backwards direction. Actually, we're turning the machine around and we're doing all the mixing and sizing in the cutter housing. So it's based on speed, so we control the sizing with speed. We're down cutting, that also helps us maintain sizing, and we're adjusting the pump based on that forward speed. Then we feed it into a paver. We can also leave it in a windrow. Then on the right, you have the multi-unit. So that's a much more elaborate train, a little bit more logistically challenging, potentially, but more for highway type work. The advantages there is we're working off of volume in the single unit. On the multi-unit, we can weigh the material. So we're weighing it. It also has a screen deck and crusher, so we're sizing it and guaranteeing a certain sizing and mixing by weight. We've achieved similar results with either. The multi-unit, you're going to be a little bit more foolproof maybe, but comes with costs and challenges. But yeah, so that's where it's really kind of evolved over time. So just some more sort of graphical illustrations of these setups. You can see kind of here the mill feeding into the paver and the way we're moving here. Mentioned that we can leave it in a windrow, and this goes for other manufacturers as well. So here they actually spread out. So there is, can do that. Then we mix everything together, better housing, and blend it with. Here they were using emulsion, but it can be foamed asphalt, and feeding it into the paver. So just some more pictures of some examples working in the field, what kind of structural issues, or not structural issues, but deformities and pavement distresses we're correcting. So it is pushing the tanker as well. Tanker's just kind of along for the ride. And yeah, so this is what you end up with out of the back of the paver. And that would be capped with a wearing course, either a chip seal or hot mix asphalt. So here's the different, obviously you've got a longer train here, more investment for the contractor, but does have some advantages. And again, that we have that closed loop sizing and weighing of material. But similar, really this is just another way to skin the cat and see how the material flows through that machine. So up here at the top, we're feeding directly onto a screen deck. Anything that's of size is just going to drop immediately on the conveyor belt below and go through the pug mill. If it's oversize, it's going to go through this crusher here and then return back onto the screen. So it is closed loop. Anything oversized, everything has to pass through the screen to get to the pug mill. So that's how we guarantee the sizing on this unit. And then in this conveyor that's going up to the pug mill, that's where we're actually weighing the material and adjusting flow additive rate based on that weight. So. And that really concludes the presentation. I will send my contact info to Trenton and Mike Dudley so that they have it if there are any questions. I appreciate everyone's time and look forward to seeing you in person sometime.